Hi guys, it's Miss Griffin here. We're taking a look at Unit 3, Skill 1, Identifying Single Transformations. If you need to pause the video to write down your essential question, please do. We do have quite a few vocab words to talk about today, as well as the different types of transformations, so this video will be just a little bit longer. Your essential question says, what are a few ways that you can identify a transformation from a graph? Think keywords. And we'll talk about what those keywords mean in just a minute. A transformation, first vocab word here, is a one-to-one mapping of a pre-image onto an image. Now there's two vocab words there that we need to identify quickly off to the left-hand side. The first one being the pre-image. Pre-image is the original figure. Whereas the image is the new figure. A rigid motion, our next vocab word, means that it's a transformation that preserves. Another word for preserves is keeps. That preserves distance / length. Distance, length, and size can all be interchanged. Preserves distance / length or size, and angle measure. Now in the next section we're going to talk about the 4 different types of transformations, some keywords that go along with them, and then also the notation. So the first transformation that we have is called a translation, and the keyword for this is a slide. You slide it left, right, up, or down. So the notation actually indicates how we slide. Capital T for transformation, and then we have these little subscripts, little letters beneath it. A and B, where A and B actually represent numbers. So A will take you left or right. I just drew those arrows backwards. Right or left. And then B will take you either up or down. And then the question says, is it a rigid motion? So remember again, rigid motion preserves distance and angle measure, or length and angle measure. So if we were to take and sketch this real quick, take a triangle, move it to the left, move it up, and redraw it. Is the distance the same? So is this side on the left equal to this side on the right? Is this angle equal to this angle here? And the answer is yes. So we're going to say yes, because distance and angle measure are preserved. Our next keyword is, or our next transformation is a reflection. A reflection is a flip. So keyword for reflection is flip. And I actually want to sketch this real quick, and then we'll go back to notation and the rigid motion question. So we start with a triangle and say we want to reflect it over this line. Then it turns itself over here. So here it says the notation is a lowercase r, with the subscript being whatever line you're reflecting over. So you could reflect over something like the y-axis, axis, or you could reflect over something like the line x equals 2. So again, lowercase r with a reflection, the line of reflection. And then it says, is this a rigid motion? And the answer again is yes, because, and I'll let you fill that in, distance and angle measure are preserved. Our third transformation is called a rotation, and the key word for that is a turn. You turn a figure around a certain number of degrees. So again, let's sketch this real quick. Say that we start with the triangle being upright, and we want to turn it 90 degrees. So then it turns itself towards the left. So with a rotation, our notation is as follows. Capital R, the point that you rotate around, and then the degree measure. For the degrees, it's typically 90, 180, or 270. And again, P represents the point rotated around. And then we have that question again, is it a rigid motion? Is distance and angle measure preserved? The answer again, yes. And again, you can write because distance and angle measure are preserved. And then last but not least, a dilation. Dilation is a shrink or grow. So we start with a small triangle and then we grow it by some scale factor, whether it's 2 or 3 halves or 1/2 or whatever it happens to be. The notation for this is a capital D with some number. That number, that K, represents the scale factor. K equals scale factor. And then, is this a rigid motion? Is distance and angle measure preserved? Well, it looks like angle measure is preserved. However, distance or size or length, whichever way you want to think about it, is not preserved. So no, because distance is not preserved. One more quick thing that I want to mention about rotations off to the side here is that rotations go counterclockwise if it's a positive degree. So rotations go counterclockwise meaning to the left if it's a positive degree. And also with rotations, you need to think about the number of turns it makes for each degree measure. So if we're turning 90 degrees, that's 1 turn to the left. If we're turning 180, that's 2 turns to the left. And then 3 turns would be 270. So we have our first example here. It says, given the diagram below, which of the following transformations best describes the mapping from quadrilateral ABCD onto A prime, B prime, C prime, D prime? Notice how I'm saying this, A prime, D prime, C prime, D prime. So here we have our pre-image being the first quadrilateral, and then our image being the primes. So we have to figure out how are we going from the first, the original, onto the image, the new. So my original is over here on the right hand side. You can see there's no primes. And then my new image is over here on the left hand side. So we have to decide what's happening here. How do I get from the first to the second? So if you go through your options, the first one says a reflection. And I love writing the keywords off to the side. So reflection, remember, keyword is flip. The second one is a translation. Translate means slide. Third, rotation. That was a turn. And fourth, slide again. Because again, it's a translation. So we have to decide what's happening here. It looks like I'm taking A and moving it to the left and down. I could say the same thing about D. To the left and down. Probably the same thing about B and C. So if I'm taking it to the left and down, that's a slide. So I can immediately cross off choice 1 and choice 3. Now I have to decide, am I sliding or translating right 7 and up 3 or left 7 and down 3? And this is why it's important to look at what the pre-image is in comparison to the image. So the pre-image was here, A, B, C, D, and the image was A prime, B prime, C prime, D prime. So again, we moved left, and then we moved down, so that would be choice 4. And then there's a follow-up question that says, does this transformation represent a rigid motion? Explain your response. This is a typical question on a short answer part of an exam. So you need to get in the habit of answering these questions and answering them specifically. So yes, because a translation preserves blank and blank. Remember that a rigid motion preserves distance and angle measure. The only one that doesn't preserve distance is a dilation. So every time you see this question, unless you've had a dilation, the answer is always yes. It's kind of nice. Flip it over, we'll see a couple more examples. So in example 2, it says, given the diagram below, state the transformation that maps triangle CLJ onto C prime, L prime, J prime, and use the properties of rigid motions to explain why the triangles are congruent. So here we're taking a look at what happened to map the pre-image onto the image, the second thing, and then how and why those triangles are congruent. So if you take a look at this picture, think of those key words. What is happening? Is it a slide? Is it a flip, a turn, or a shrink and grow? Hopefully you can see that L gets flipped over the line to become L prime. J gets flipped over the line to become J prime. So a flip takes us back to something called a reflection. So you could say a reflection over, and then you have to give the line that it's reflected over. So it's the line that lands in the middle of the points. So in the middle of L and L prime, I see the x-axis. In the middle of J and J prime, again, I see the x-axis. So it's a reflection over the x-axis. Another way that you could say this would be by using the notation, lowercase r, x-axis. Again, either option is acceptable. Then it says use the properties of rigid motions to explain why the triangles are congruent. So we can say that reflections over the x-axis preserve those two special properties, blank and blank. If you need to look back, please do. Otherwise, pause the video while you write it and then check in with me to see if you're correct. So reflections preserve distance and angle measure. So triangle CLJ is congruent to triangle C prime, L prime, J prime. Example 3 says, in the diagram below, triangle ABC is mapped onto A prime, B prime, C prime. Determine whether or not the triangles are congruent. Explain your response. So here it looks like we start with a smaller triangle in purple and it's made into a larger triangle in green. If we are growing, would the triangles be congruent? Hopefully you said no. So no, triangle ABC, this is a new symbol for you, is not congruent. So it's the congruent sign with the slash, means not congruent. Is not congruent to triangle A prime, B prime, C prime, because, remember, explain means a because. Well, you have to think of what transformation happened here. If I'm growing, that's called a dilation. No, because dilations do not preserve one special property. If I'm growing, then it does not preserve size or distance or length. One of those three words needs to be written here. So again, dilation is the one and only transformation that does not preserve distance. Therefore, the triangles are not congruent. And last but not least, we have example 4 here. Which of the following best describes the transformation that maps triangle PKT onto the primes? P prime, K prime, T prime. So here, if I look at my notation, I see lowercase r's and I see capital R's in my choices. A lowercase r, remember, stands for reflection. A capital R stands for rotation. I do have a little trick that may work for you to help you remember the difference between the two. Rotation starts with the letters RO, and you can make an O out of the capital R. So capital R for rotation. I don't know. That might help. It helps me to remember, so maybe it'll help you. So we've got to decide first, is it a reflection or is it a rotation? And depending on which it is, we have to narrow it down afterwards. So I see that the black triangle PKT gets mapped onto the primes by turning. So a turn eliminates choice 1 and choice 2 because reflection is a flip, rotation is a turn. We are turning about the point called the origin. The origin is 0, 0. Origin equals 0, 0. So now we have to decide how many degrees we are turning. Well, if I only went one turn in a counterclockwise direction, counterclockwise means positive degrees. Both of these are positive. So I'm just going to write counterclockwise as a little note. Remember before we said one turn is 90, 2 turns is 180, and 3 turns is 270. So if I went one turn to the left, that is a rotation of 90 degrees. If you need to go back and rewind the video at any point in time, please do. Otherwise, get working on practice in your summary and CFU. See you later.